Okay, this is the relative rates of nucleophilic substitution reactions, and now I'm doing part B, which is determining the factors affecting the rates of an SN1 reaction. So, first I'm going to look at the effects of the structure. So, again, let me try this, see if it's better. It might be too bright with that light on, but I can't tell. I think I'll keep it on. All right, I'll hold the test tubes in front of the camera. So what I'm going to do is, it says to put 2 milliliters of a 1% solution of silver nitrate in absolute ethanol. So I've already done that. There's 1 milliliter of the, 2 milliliters of the absolute ethanol with 1% silver nitrate. And I'm going to add a drop of 1-bromobutane, 2-bromobutane, and then 2-methyl-2-bromopropane. So again, these are 3 isomers that just have the bromine is either primary, secondary, or tertiary. So I'm just going to add 1 drop at a time. It might be a little bit hard to do it because you kind of gotta watch closely. I'm going to try to do it as fast as possible. And I've also numbered the test tubes 1, 2, 3, so I can stir them all at the same time. So let me do that. Stopper them and stir them. But already you can see that this one, which might be hard to tell, let's see if I can get it right in front of it. This one's number 3 that turned white almost immediately. So that precipitate again is what we're looking for to show that a reaction has happened. So almost immediately the 2-bromo-2-methylpropane precipitated. The number 2, the 2-bromobutane, which is secondary, is starting to cloud a little bit. It's getting a little bit cloudy if you sort of hard to see with this. I don't know that the white works. If I put it in front of the black, see if I can curve that down and put it in front of the black, you can see that the number 3, which has the 2-bromo-2-methyl, precipitated right away. Number 2, which is the 2-bromo-2-butane, which is secondary, has clouded up, but not nearly as fast. And then the 1-bromobutane has not clouded at all. All right, so I think that's good. So now I'm going to do the second part, the effect of the leaving group. So this time I have already measured 2 milliliters of the 1% silver nitrate in absolute ethanol. And this time I'm going to put 2-bromo-2-methylpropane on the left and 2-chloro-2-methylpropane in the right. So we're going to see the effect of the leaving group. Let me get ready with my test tubes. So let's see if I can add these at the same time. See if I'm ambidextrous. All right, I'm just adding about a drop. I'm going to cover them. Oh, this time whoops. The 1-bromo, I don't know if you could see that if that was in the camera. The 1-bromo, like, immediately turned cloudy. The 2-chloro-2-propane has yet to turn. So the 1-bromo-1-methylpropane turned very quickly, and the 2-chloro-2-methyl. So again, I think we saw this on the last part, that the bromine is definitely a better leaving group than the chlorine. Okay, so this time we're doing the effect of the solvent polarity. So On the left, I've got 2 milliliters of the same silver nitrate and ethanol that we've been using all along. And on the right, I've got silver nitrate in mostly acetone, 95% acetone. So we know ethanol is polar protic, acetone is polar aprotic. And so I'm going to add a drop of the 2-bromo-2-methyl propane into each. I've got them labeled 1 and 2 so we can tell the difference. Let's see if I can put that here. They both go pretty quickly. However, the one on the left, which is the ethanol, is definitely darker and definitely quite a bit more precipitate has formed. So the ethanol is definitely a better solvent than the acetone for this. I don't know if you can see it, so let's see if I can put it down here. So again, the one on the left, which is an ethanol, they both turned pretty quickly, but the one on the left is much more precipitate formed and much darker, and formed maybe just a slight hair quicker. Okay, so the ethanol went faster than the acetone. All right, so now I'm ready to do the determination of the rate law. And it's going to be a little tricky to do it by myself. So I decided to take the alternate, and I'm going to do one at a time and record the time it takes for precipitation to occur. So we'll see if this works at all. So in this test tube, I've taken 10 drops of 0.1 molar. Let's move the paper so we can see it better. You can read it. 10 drops of 0.1 molar 2-bromo-2-methylpropane. And then I'll do the next one next. So I've got 10 drops of 0.1 molar, and what I'm going to do is I'm going to add 1 milliliter of the silver nitrate solution. I'm going to start my stopwatch as I add it. Let's see if I can have 3 hands at once. All right, ready, set, go. It got cloudy pretty quickly. The precipitate formed within a few seconds, and I'm watching it kind of. All right, so let's stop it. Precipitate started forming maybe about 5 or 6 seconds afterwards. I see precipitate is continuing to form. That, let's say 5 or 6 seconds. I'm going to do the same thing. It's a little bit hard to do. Again, I'm going to start the stopwatch just as I pour it. Now that one happened like within 3 seconds, and it's, if you can see it, it's already the one with the 0.2 molars already much faster. It's formed about definitely more precipitate, almost twice as much. So the 0.2 molar, I would say the first one took maybe about 6 seconds. So I'm kind of maybe making up the data a little bit because it's hard to watch everything at once. The 0.1 molar took about 6 seconds to start forming, and the 0.2 molars took about 3 seconds. So about twice as fast. And you can also see that the 0.2 molar definitely has more precipitate than the 0.1 molar. So there's more product. I mean, I guess that makes sense, but it also happened about twice as fast. All right, so finally, the last piece of the data is now we're going to test the concentration. So in that last one, we were testing the concentration of the the substrate, the 2-bromo-2-propane. So 2-bromo-2-methylpropane. So we saw that when the concentration of the 2-bromo-2-methylpropane was doubled, the rate pretty much doubled, so the substrate. But now what we're going to do is we're going to see how the the change in the silver nitrate will change it. So in my first test tube, I have 1 ml of silver nitrate in ethanol. And then in my second test tube, I only put a 1/2 ml of the silver nitrate, and then I added a 1/2 ml of ethanol. So basically, the second one is half the concentration of the first one. And now I'm going to add a milliliter of 0.1 molar 2-bromo-2-methylpropane into each of them. And so this time the concentration of the silver nitrate is changing. And we're going to see, I'm going to do them one at a time again like I did last time. And we're going to see, I'm going to start it and time it all at the same time. And we'll see which one goes faster. So I'm going to start it, add it. Oh, it just happened immediately. I'm saying maybe 2 or 3 seconds. And so let me do the same thing with the other one. So I've got to get a milliliter of about a milliliter of the 0.1 molar 2-bromo-2-methyl. It's not coming out. It's taking me a while here. All right, let's see if that's enough. Not quite. I'm probably mumbling over here because I don't have my microphone. All right. So that's 1 milliliter. So now I'm going to do the same thing. I'm going to reset it. I'm going to hit the timer as I pour it in. Start, pour it in. Again, it happened almost immediately. I would say about 2 or 3 seconds. So I don't believe the concentration of the silver nitrate had any effect. They were both, in both cases, whatever concentration of the silver, as long as there was some there, the reaction took place, but the concentration of the silver nitrate did not affect. So they were both about 2 to 3 seconds. So that is all the data for this SN1, SN2 lab. So thanks for watching.